Okay. Welcome to Computer Aided Machine Drawing Lab. Today we are going to see how to make 3D modeling of protected flange coupling. Okay, and we are going to make three parts in 3D model. We are going to assemble the parts together in the make the assembly, and then we have to plot the assembly drawing as given here. So the question is, given in the figure is the details of protected flange coupling. So these are the detailed drawing of the protected flange coupling. Uh, we have to draw the assembly. Okay, so not the detailed drawing. We have to draw the assembly, assemble all the parts and draw the following. So we have to draw front view, upper half in section and side view. Okay, so we already have front view, upper half in section for the details. We have to assemble the parts and we have to draw the lower half. Okay, so here we will start with the drawing. So we'll go to AutoCAD. Okay, whenever we are opening a new file, we will make sure that we are switching to 3D modeling. Okay, now once we are in the 3D modeling, we can see the grid. Okay, and we will change our view to southwest isometric so that we can see all three axes. Okay, now we will see where we have to start. So we will take the shaft first because it is the simplest part to be drawn. So shaft, and we can see the shaft in front view, it is only the rectangle that is seen. So when we have to draw a cylinder, okay, of the shaft, we will have to draw it in the left hand view because the circular face will be seen in the left hand. Okay, and in most of the cases, for example, this flange, you can see all the circular faces like the 92, 214, all these circular faces are seen in the left plane. Okay, so our most of the parts of 3D modeling will be in the left plane. So first let us set this in the left plane. So our UCS will be setting in the left plane, and you can see our grid is aligned in the left plane. So I will see here now the shaft dia is 60. What should be the total length? So the shaft should be inserted inside the flange in such a way that it will, this edge should reach here, okay, in this flange A. So this is flange A and shaft A, okay. However, respectively, this will be flange B and shaft B. So in flange A, when the shaft A goes in, the total width of the flange is 80, okay. So our shaft should come at least something out, okay. So we will take at least 20 mm outside, okay, the shaft 20 mm outside. So here the total length of the shaft will be 80 plus 20, that will be 100. So dia 60 by 100. So we can directly go here and we can make a cylinder. Okay, in the left plane we'll make a cylinder. Click anywhere for the circle. Okay, for diameter I will press D, enter, and I will enter diameter 60. Now I will extrude and I will enter length 100. Okay, okay, my layer was in center, so I will again switch it back to by default layer 0. Okay, so whatever I draw, it is in the default layer. Now I will see this in the conceptual, and you can see this clearly a cylinder or is drawn, okay, or it is created in the 3D modeling. For time being I will just switch off this grid. It is not required as such now. Okay, so we have the shaft. Now what we require in the shaft is the keyway. Okay, we have to get the keyway. Now the keyway, we can see the shaft dia is 60. Okay, so if the shaft dia is 60, and what should be the keyway? Keyway dimensions. So for the keyway dimensions, if we take or let's say key dimensions, we have shaft dia D is equal to capital D is equal to 60. Okay, so accordingly my width of the key, width W of the key will be D by 4, which is coming out as 50. The thickness of the key, I am looking at key, thickness of the key, that is T, is equal to 2/3 of width. Okay, 2/3 of width, so that will be again 10 mm. Okay, so we have the thickness and we have the width, and we'll get all the other since we are taking here as a jib headed key, we are selecting jib headed key. Okay, our head thickness will be, that is B, will be equal to 1.5 times thickness, so that is 50. Now head height, that is H, is equal to 1.75 times P, which is equal to 17.5. Okay, so we have all the dimensions of the key. Length is remaining, so length L is equal to uh, we can take almost 80 or 70 will also do. 70. Okay, so almost we can take D to D point 1.5 times D, it is D to 1.5 times D. Okay, anything in this range, and so we are taking 70. Okay, so let's move back to AutoCAD and make a keyway. So in a key, first we'll make a key, and then accordingly we will make align that to a shaft. So for making the key, I will directly go to the box. Okay, I'll give the cross section. My cross section is 15 by 10. Okay, so my cross section width is 15. I'll press tab, so it will go to the thickness and 10 mm. Okay, I'll give the length. The total length, right now I am making only the keyway, so according to the key dimensions, so I will take 100 as the total length, which is the length of the shaft. Okay, now I will make this, and I will move this from the half. I'll move this from the half. You will get a center point. If not, you can make a line like this. You can make a line and you will get the center point of it. So select, move from the center, that is the midpoint of this line. Okay, and put it on the quadrant point. You can see this is the quadrant point of the shaft. Okay, at the half. So you have half outside and half inside. Okay, now I'll make the slot. In order to make the slot, I will use the command subtract. Okay, select the solid, that is the cylinder first, press enter, and then select the keyway and then press enter. So here's the keyway that is ready for us. Okay, it is a through and through keyway. It is not ending in between. It is through and through along the length. Okay, so similarly we want one more shaft, because if we see the details, it is on the other side. Only that this shaft will be rotated because the keyway is rotated. Okay, so here you can see the thickness of the keyway, whereas here you can see the width of the keyway. Okay, so I will take one more shaft. I will make one more copy of this. Okay, and rotate it. Now where to rotate? Whether it is in front or back. So from this keyway, you can see here details. It is clearly seen that even if the section is done, okay, and the slot is not visible towards the front, okay, or towards the object who is looking towards this particular flange. So obviously the keyway is on the back side. So we have to rotate this keyway on this side. Okay, so because this is going to be our front, this is front, this is back. So let us do 3DR, that is 3D rotate. Select this, Okay, select the proper angle or proper the axis of rotation, and in my case I'm taking this red color. Okay, and I will, you can also click on the ortho mode so that you can see here the preview. Okay, and rotate it. So one shaft is having keyway at the top, the other on the back side. So two shafts are ready. Now I have to make the flange. In order to make the flange, first we will start with the dia 92 and 5. So I will go with dia 92. Okay, I will make a cylinder again, dia 92. Okay, and the thickness is 5 mm. Okay, so if we have the cylinder of dia 92 and thickness 5 mm. Okay, so now we are going to make the flange, but before making the flange I will save my work. Saving your work is very important. Okay, I will save my work giving a file name. Do save your work regularly. It is just a matter of pressing Ctrl S on the keyboard. Okay, which will save your work regularly. Now here we are going to we have already drawn this dia 92 and 5. Okay, the next cylinder we are going to take is the dia 214. We are going to take the outer cylinder. Okay, so dia 214 and the thickness is 40 for the outer cylinder. So okay, so cylinder, draw anywhere and then we can move this. Dia 214 and thickness is 40. Okay, now we have to merge this two cylinders, so dia 92 and dia 40. So we will merge this. Okay, I will take the from the two centers, I will take the first one and put it on the back. Okay, because these two centers are concentric to each other. Now the next cylinder we have to make is the inner cylinder. For the inner cylinder, the diameter would be 214 minus 5, that is on this side, and minus 5 on the other side. So it is total minus 10. So the total diameter comes around at 204. So I will make a cylinder of dia 204. Okay, and what is the thickness? Thickness is 40 minus 22, that is 18, the remaining one. So 18, 18. Okay, move this in such a way that we are taking the front face of the cylinder to front face of this cylinder, that is 214. Okay, and when we see this in 3D, in the conceptual mode, they are merging into each other because we want a slot. Okay, we want the slot. So you can see this is the slot that is freed up. Okay, in order to create a rim. Okay, so now we will go to subtract and make that rim. So subtract, I will select the outer body first, press enter, and then the inner body, press enter. And if you see now in conceptual, we have our rim which is ready. Okay, so next we have the hub. Okay, the hub is there, and the total diameter of the hub is given to us as 120. Okay, and the total thickness, okay, we can start from here. If we start from here, the total thickness will be 80. Okay, minus 22, okay, which comes around at 58. So this total length will be 58. So I will make one more cylinder. Okay, cylinder dia 120 and thickness is 58. Okay, once this is done, move this from the center to the center here. Okay, and you can check whether it is coming on the same center or not. Yeah. Okay. Now, before we create these holes, what we'll do is we will first make a union, because these three cylinders, this one, two, and three, they are separate parts. So I will make a union. So I will select union, select all these three cylinders, and press enter. So they are one part or one object now. Okay, before doing any fillets, okay, we have to make sure that we are doing this union function, okay, so that the fillet direction will be correct. Okay, next we are going to make make these holes. Okay, these are the holes for the bolt that will go through. Okay, and these holes are given as dia 18 4 numbers, dia 18 4 number holes. Okay, dia 18 4 number holes, and it has a PCD of 158. Okay, so first we will make a PCD dia 158, a simple circle of dia 158, which is the PCD. Now I will make a cylinder of the same size. Okay, so dia 18 by 22. I can take length a little bit more. Okay, so dia 18 and length may be 25. Okay, because we have a through hole. Okay, now here you can see 4 number of holes, and you will see here array polar. Okay, so select this and give the center of the polar. Okay, number of items is 4. Just click here and automatically it will take the 90°. Make sure this associative is unchecked. Okay, unchecked. This is checked, this is unchecked. Okay, we want all these bodies to be individual. Close array. Okay, and we have all these individual bodies here. Now these bodies are to be transferred on this surface here. Okay, so I will select this 1 2. Okay, select this and I'll move from here, from the center, and I will place it at this center. Okay, so they are aligned properly with the face. This side obviously it will come out by 3 mm because we have given 25 mm as the length. Now I will have to select them and subtract them because we need to create a hole. So subtract, select this outer of body first, press enter, select this cylinders, you can filter out, select the bodies properly, and 4. Okay, and then press enter. So you have the holes ready. Make sure they are through holes. Yes. Okay, next is we are going to make the shaft hole here. Okay, okay, so now we are going to make the shaft slot. Okay, so the shaft slot is dia 60, but we also see here that there is a keyway. Okay, there is a keyway in the hub. Okay, so we have to make that also. So we, along with the shaft hole, we will also make the keyway, and then we will subtract it together. So first I will make a shaft, same size, dia 60 and length 120. I'll make it more only because it has to go outside, because total is 80 plus 5, 85. So you can take 100 also, no problem. And double click here and I can change this size to 100. Okay, now I will make the key. Okay, again, so I'll go to box, I'll give the key size 15 by 10, that is the cross section, and this is also 100. Okay, once this is done, I will move this again, same thing, from the center to the quadrant point. Okay, now instead of subtract which we did for the shaft, here we are going to make union. Okay, so I'll go to union, I'll select both these solids and press enter. Okay, now after this I will say move. Okay, move from the center and place it on the center. Okay, so here in this way we will be able to create shaft or also and the keyway both together. Okay. Now here I will make the subtract outer body minus the shaft, select it one side, then press enter. Okay, so our shaft hole as well as the keyway is ready. Okay, now the only thing that is left in this flange is the fillets. So if you see the fillet, you can see the fillet diameter here, that is total thickness is 5, means the diameter here is 5. So obviously the radius of the fillet will be half of it, that is 2.5. So everywhere I will take that diameter radius as 2.5. Okay, so I will go to flange and I will say solid fillet edge, select, go to radius and change the fillet because my by default radius is 1. So always change the radius first, 2.5, press enter. Now select the edges. Okay, select the edges. You can also check which edges are there. So 1, 2, 3, 4 and 5. 5 edges are there. So I will select 1, 2, 3, 4 and 5. Total 5 select edges. Press enter once so you get preview and press enter again to complete the command of fillet. And you have fillet on the flange. Now we will create the flange B for this. Okay, so you can see the flange B is just a mirror image. Okay, except the only correction here is that this dia 92 is extruded and here we have the cavity of this extruded part. So we have dia 92 and the cavity thickness is 10 mm. Okay, or cavity depth is 10 mm. Okay, so first we will make a mirror image. Okay, and in order to do a mirror image I will take help of this circle only. Okay, or maybe a plane. So I will need a 3-point plane for that. Okay, so let's make a plane, just a rectangle in the left plane itself. So this is going to be my mirror plane. Okay, now I will go to mirror, 3D mirror, select the flange, press enter. Now it is asking me the 3 points of the mirror plane. So I will give 1, 2 and these 3 points. Do you want to delete the source? No, I want a copy of it, and you can see there is immediately one created. Okay, now the only thing is we have to move this a little bit outside. Okay, yeah, we have to move this outside and then we have to make this, we have to correct this. We need a cavity and then we will pull it back to its position. Okay, so let's make the cavity. So if we see the cavity, we just have to make a dia 92 cylinder, but not of thickness 10. It is thickness 10 but plus 5 mm. So this will go inside, subtract 5 mm and then 10 mm. Okay, so it is total 15 mm. So cylinder dia 92 and thickness 15 mm. Okay, select this and move this to our position, to the last face. Okay, after moving we'll just check whether it is perfect. Okay, Now I will make the subtract function. Select the outer body, select the inner body, present, and we have the cavity ready. After we have made the shafts and the flanges, we can also make this hexagonal bolt and the nut. I have already shown you the videos of how to make the nut and the bolt. You can go there and see there. Okay, and so I will save that time here. And but we want four number of bolts, so we will make the copy of this on the same PCB. So I will make a circle of dia 158. Okay, I will make one more copy of this because I want one for bolt and the other for the nut. So I will copy this here. Sorry, instead of copy, I will move this. Move from the neck. Okay, from the neck center of the neck, and I will place it on the quadrant, top quadrant. Okay. Similarly, for the nut, copy. You can see the fillet is on the opposite side. Okay. I will take it from the center of the back face and put it on the quadrant. Okay. So now here I will make the polar for the bolt first and RA polar for the nut afterwards. So first for the bolt, select the body, select the center. We know that it is number 4 items. Okay, and associatives are unchecked. Close array. Okay, repeat the same for nut. Select polar array, select the body, the center, select the center, select 4 numbers and close array. Okay. Okay. After this, now we will make the key. So we already have the key dimensions here. Okay, we already have the key dimensions. The only thing is that we need to make this key in the 3D modeling. So what we'll do, I'll show you the 2D of the 3D model. Okay. So in order to make the key, first we will go to the front. We will change our view from left to front because our key profile will be seen in front, and then we will extrude that in the thickness. Okay. So first I will take the line. I will give the total length. Okay, I will activate this. Okay. Now I'll give the total length, total height. Total height of the head is how much? 17.5. So I will make this into two halves. So first half will be 10 mm, which is the actual thickness of the key, and next is 7.5. Okay, so I will have two lines here. You can see the top one is 7.5, the bottom one is 10. Okay, now the key width, the head is 15, that is B. Okay, so I will take this as 15. Okay, next I will bring this down by 7.5 again. Okay, and from here the total length will be 70. Okay, so it is this, the square portion of the width will be 70. Okay, the remaining part is 10 again, coming down and then joining here. Okay, we can make this. So I will have a line of 10, right, the end point of 10 and the midpoint of this. Okay, I will join them with a line so that I can get a 45-degree angle, because this is also 7.5 and this is also 7.5. So once this is done, I will use the trim command and trim the edges which I don't want. Okay, my profile for the key, jib headed key, is ready. I'll use the command join first, join and then extrude. Okay, so join, so it will be one edge now. Okay, and now I can extrude this into the thickness and give the thickness of how much? So sorry, width of the key is 15, so utilize. Okay, So we have the key which is ready. Okay, we want one more key copy because there are two number of shafts. So one more key. Okay, and this key will be rotated on the other side as per the key way. First, I will have to make a mirror image. So 180, rotate by 180. So I will have a mirror image and then I will rotate it PDR as per the shaft diameter, shaft alignment. Okay, on the other side. So the head will go on the other side. Okay, you can see here. Okay. So all the details of the uh, that is part modeling of the flange protected flange coupling is ready. Our next video will consist of how to make the assembly of the protected flange coupling.